So let's take a look at what we actually just did in that question, because there was a lot of things that we actually did. So the first thing that we did is we found the hypotenuse by finding the vector from the line to the point. So we needed a point that lay on the line, we were given a point, and then we found that length there. That was the first part of this question. Now once we found the length of the adjacent side, then we can do Pythagoras. So we're sort of halfway towards the question. We found one of the sides, we're trying to find two of the sides. Now, as we don't know where this point is, we can't find this length directly, so we have to do a couple of other things. So the next thing we did is we found the length of the direction vector, and we created a unit vector. And the reason we did that is so when we do our third step, conveniently when we work out our third step, we'll find the length of the adjacent side. Step 3, calculate the dot product between this vector and this direction vector that we had. Once we've done that, that's our adjacent length. And then as we know the length of the hypotenuse and we know the length of the adjacent side, step 4 is we're going to use Pythagoras to find the length of the shortest side. So although we did this originally by algebra, from now on we want to try and do this by vectors to practice this method. The reason why we do this method is it might not seem so easy for 2 dimensions, but once we get to a 3rd dimension question, then actually we can apply this method to the same thing, which we wouldn't have been able to do if we did it purely algebraically. We should know, that's assuming that we know how to find the vector from one point to another point in 3 dimensions, and it should just be the second vector subtract the first vector. Also assuming we know how to find the length of a vector in 3 dimensions, which is Pythagoras, a squared plus b squared plus c squared, all square rooted. Find the length of that direction vector and then create a unit vector, so Pythagoras again, then divide by whatever the length was. Dot product in 3 dimensions, multiply the top elements together, middle elements, bottom elements, and add them together. And then for the 4th step, we should have a Pythagoras question where we just know the length of the hypotenuse, and we know the length of the adjacent, and then we can work out the missing side. Now let's look at one more question, and this time I made this slightly easier. So instead of making this Cartesian equation, I've actually given the vector equation of the line to try and make this a little bit easier. Also, I've put up all the steps that we're going to do, and that should also help us to make this a little bit easier. Now, first of all, 29.2, I want to change into a vector to make this a little bit easier. So find the hypotenuse by finding the vector from the line to the point. So I'm going from 0,4 to 29.2. So an increase of 29 and a decrease of 2, so that would be 29, negative 2. And then we can do Pythagoras on this to find out the length of that hypotenuse. Find the length of the direction vector. So this is our direction vector. So to find the length of Pythagoras, 12 squared plus 5 squared all square rooted gives us 13. So if we divide by 13, this will be length 1. So 12 over 13 and 5 over 13. We've then got to find the dot product. Now the dot product is for the 2 sides. So this was the first side that we found. And then this is our unit vector, which goes along the direction of the line. So I'm going to do the dot product of these 2 things together. And you should check that this times this plus this times this does indeed give you 26. Now once you've got your 2 side lengths, this length and this length, then use Pythagoras to find the length of the 3rd side, and you're done. So although it looked very complicated on that first example we did, those 4 steps actually, once you get used to them, they're actually not too bad, but you just need to remember that procedure as you're going along.